Okay, so this is the rest of the video for 3.2. My dog jumped up onto my keyboard and stopped my last video, so I had to restart a new video. So this is the extension of the first one. So to simplify the square root of 20, because it can be simplified, you're going to find, I'm going to use 5 and 4. I'm going to pick that carefully because I know 4 is a perfect square. I could have used 10 and 2, but then I would have had to break down the 10 into 5 and 2 and put the 2's together. So it would have been a longer process. So I'm trying to get these perfect squares because the square root of 4 is 2, and then the 5 is not a perfect square, so it has to stay under the square root. So that's the simplified version. This is an exact number how it is. This is an exact number how it is. As soon as you put it into your calculator and you round it, you've just estimated it. So we're trying to keep these exact. So the square root of 75, I'm going to use 25 because that's a perfect square, and 3. Square root of 25 is 5, and then the 3 again has to stay underneath the square root because it's not a perfect square. 80, I'm going to use the square root of 4 and 20, and it might take you a little bit to find this pair. And then 20 can be simplified into the square root of 4 and the square root of 5. So once you hit a perfect square, you can stop because we know the square root of 4 is 2. The square root of 4 is 2. Square root of 5, so that's 4 the square root of 5. And you can keep going here. I might do a couple more. Maybe I'm going to have you do the rest of these though. 72 is the square root of 9 times the square root of 8. And then the square root of 8 is the square root of 4 and the square root of 2. So the square root of 9 is 3. The square root of 4 is 2. Square root of 2, so that's 6 the square root of 2. So you're going to finish these other ones just for practice. Another thing that we're going to look at is solve the following equations using the square root method. Answers must be exact, which means you can't have a decimal, you can't round. So if I'm doing this using the square root method, I basically am getting the square by itself. So I would have to move the 20 over, and then I'm going to square root that. So I'm going to end up with x. Anytime you square root an x squared, it's plus or minus. And then 20 is the square root of 4 times the square root of 5, which is 2 the square root of 5. The next one, I'm going to move the 25 over. I'm going to divide by 5. And then I'm going to square root both sides, so x is going to equal plus or minus the square root of 5. And we've done these before in Algebra 2. So this one, this is already by itself, so I'm going to square root both sides. This one's a little different. So the square and the square root cancel out just like they did before. I'm left with what's under the square root, which isn't just an x, it's x minus 6. And that's going to be plus or minus, and I could simplify this now if I wanted to. Square root of 9, square root of 2. So 3 the square root of 2. And now I need to add 6 to both sides. So then x equals, make sure that 6 ends up right there, not right there. So it's going to be 6 plus or minus 3 the square root of 2. And then the next one, I'm going to move the 24 over. I'm going to divide by 3. And then I'm going to square root both sides. And 8 is the square root of 4 and the square root of 2. So it's going to be 2 the square root of 2. You could pause this if you need to, just to process it. So on this one right here, I'm going to move the 40 over. I'm going to divide by 2. And then again, I'm square rooting both sides. Plus or minus 2 the square root of 5. So those are just some practicing, I will test you on that. The next thing we're going to look at is a quadratic formula, which you should already know. So if you could pause this video and write it out for yourself. So hopefully you paused this video. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And the equation, what did that need to look like? It's ax squared plus bx plus c equals 0. And that's where I'm getting the a, the b, and the c. So just some number sense I want to talk about here is the discriminant. The discriminant is what is underneath the square root. That number, whatever that number is, that's the discriminant. So if underneath, so if I have x equals negative b plus or minus, and I have a positive number underneath here, I'm going to have two answers. It's going to be negative b plus whatever that is and negative b minus whatever that is, divided by 2a for both of those, right? So if you have two answers, that means that you're going to have two real roots. So it could look like this. There's one of them, and there's another one. Or it could look like this. There's another one. So depending on which quadratic you have, it's going to cross over the x-axis twice. If the discriminant is 0, so I'd have x equals negative b plus or minus the square root of 0, which is just 0. So then this is gone because that's just adding and subtracting 0. So I just have one answer here. And what's that is going to look like on here, it could be a parabola like that where it's just crossing over at the vertex. Could be one that looks like that, or it's just crossing over, so it just has one real root. So another root would be imaginary. And then the last one is x equals negative b plus or minus the square root of, and if that's a negative number, that's going to be imaginary root, so that's going to look like this, so it's never going to cross, or it could look like this. It's not going to cross over the x-axis at all. So those are the number of real roots, and that will help you know what you're looking for. So solve the following quadratic equations using the quadratic formula. Answers must be exact. Without a graphing calculator, show all your work. So this one here, you'd have x equals, and here's my a, here's my b, it's the negative, and here's my c. So it's going to be the negative of negative 6 plus or minus the square root of b squared, and I'm just going to write this. It's always a positive number. Negative 6 squared is negative 6 times negative 6, which is 36, minus 4ac all over 2a. And same with this one here, the negative of negative 6, you could have just wrote positive 6 on that. So the the next thing I'm looking for is, what is this discriminant right here? What number is that right here? So I expect you to put that in your calculator, because that's kind of a big deal that you did that right. So minus 4 times 3 times negative 12. This is going to be 180. So you're going to have 6 plus or minus the square root of 180 over 6. You cannot cross those out because this is, you have to do this whole thing. It's adding and subtracting. So the square root of 80 is going to be the square root of 9 times the square root of 20. And the square root of 20 is the square root of 4 times the square root of 5. So that's going to be 6 plus or minus. So I have the square root of 9, which is 3, the square root of 4, which is 2, the square root of 5. So that's going to be 6 square root of 5 over 6. So in order to reduce this, you have to have factors. So I'm going to factor out a GCF on the top of 6. And when I do that, I'm left with 6 times 1 is 6, plus or minus 6 times the square root of 5. If you distributed that back in, you should get the original. Be really careful here. Very common mistake is for students not to put that 1 there, just to put plus or minus the square root of 5. So be really careful with that. Now I can eliminate those 6's, and my actual answer is 1 plus or minus the square root of 5. And I am looking for 2 real roots because this is a positive number right there. So that is my answer using the quadratic formula, and you will have one of those on the test. This one right here, this is my A, this is my B, this is my C, and you could rewrite it if you wanted to, if that helps you. So I would have x equals negative of negative 3, which is a 3, plus or minus the square root of, oops, I did that wrong, 4, it's going to cross that one off, 4, so negative 4, plus or minus b squared, which is 16, minus 4ac all over 2a. So I have 16 minus 4 times negative 3 times negative 6. And that's going to end up to be x equals negative 4 plus or minus the square root of negative 56 all over negative 6. And we are going to keep going on that one. I made a little mistake there. I had to pause it and find it for a second. This should be a positive, which makes this an 88. So I'm going to find the perfect square in 88. 4 goes into there 22 times. 22 is 2 and 11, so that's not a perfect square in there. So I'd have x equals negative 4, and then I have plus or minus 2 the square root of 22 over negative 6, and this is another one that I have to find the GCF for. So be really careful with that. So I'm going to take out negative 2, just because that's negative. So I'm left with a 2 plus or minus square root of 22 over negative 6. And if you distribute this back in, that's going to be negative 4, and that's going to be a negative 2. So this would be, instead of plus or minus, it'd be minus plus, doesn't matter. Still going to be plus or minus. And then I'm going to simplify that. So that's going to be 1/3. So then my final answer here is, that's just going to be 1 out there. So I can just say 2 plus or minus the square root of 22 over 3. So I'm looking for 2 roots on that one. Here's 3 other solving using the square root method or quadratic formula. And this first one here I would use, being that you're missing the x term and you only have an x squared term, you could use the square root method, which is the fastest. So you'd have 2x squared equals negative 40. You'd have x squared equals negative 20. And then you square root both sides. So you end up with an x equals plus or minus, and I think of negative 20 as negative 1, 4, and 5. So that negative 1 is going to come out front as an I. The square root of 4 is coming out front, so it'd be 2i, the square root of 5. So I have 2 actually imaginary roots, and remember that does not cross the x-axis. This one here, I would also use the square root method over the quadratic formula. So I'd move the 7 over, so I'd have 2x plus 1 squared equals negative 7. And then I'm going to square root both sides. So I have 2x plus 1 equals I square root of 7. I'm going to bring that negative 1 out. And then I'm going to subtract 1. And that should be a plus or minus I square root of 7 minus 1. And then I'm going to divide by 2. That whole thing by 2. So I'm going to say negative 1 plus or minus I the square root of 7. I'm just going to move this in the front so it's in the right format, over 2. Again, these graphs will be parabolas that will not cross the x-axis. The last one, being there's an x term, I'm going to use the quadratic formula. I can't use the square root method. So these two I could, and I will because they're the quickest. But if I can't, then I'm going to have to use the quadratic formula. Negative b, which is 5, plus or minus the square root of b squared, which is 25. It's always positive. Minus 4 times a, which is 1. Don't even need to write that. Times c. All over 2 times a, which is 1. So x equals 5 plus or minus, and then you're going to go 25 minus 28, negative 3 over 2. So then x equals 5 plus or minus I, the square root of 3 over 2. So there's some imaginary roots, so you can see them. And these are all exact numbers. Here is your homework. Be careful that you do them. If I have extra special instructions that I'm giving you, then be sure this would supersede the instructions in your book. So you follow the instructions in your book unless I show you something different that I'd like you to do.